Section 8.1, sequences and series. Write the first 14 terms of each sequence. Section 8.1 is a mixture of a bunch of different types of sequences. It's kind of an introduction to get you used to terminology and notation associated with sequences. In letter A here, A of n equals 3n minus 2. When you see a subscript like this, A of n, the n represents the term number that we are talking about. So in this case, if we want to write the first 4 terms of this sequence, we are plugging 1 in for n. If I want to find the second term of this sequence, we plug in 2 for n. If I want to find the third term of this sequence, I put in 3 for n, and we continue evaluating. Fourth term then is 3 times 4 minus 2, and there are the first 4 terms of this sequence. So the sequence would look like 1, 4, 7, 10, and so on, going on forever. So that tells us how to find any specific term number or the nth term of a sequence. A of n equals 3n minus 2. Letter B, A of n equals 3 plus negative 1 to the n power. So we need to again find the first term, the second term, the third term, and the fourth term. First term, plug in 1 for n, we get 3 plus negative 1. Plug in 2 for n, we get 3 plus 1. Plug in 3 for n, and we can see that the only thing that is going to change here is whether we are adding or subtracting 1, and that is dependent upon whether the exponent is going to be an even exponent or an odd exponent. An negative number raised to an odd exponent, remember, is always negative. A negative number raised to an even exponent is always positive. So the odd ones are going to be 3 minus 1. The even ones are going to be 3 plus 1. There are the first 4 terms of that sequence. Write the first 5 terms of this sequence. We're going to do the same thing. If I want to know the first term, that means I'm plugging in 1 every place that I have n. So our first term is going to be negative 1 to the first power over 2 times 1 minus 1. Simplify, we end up with negative 1 over 1, which is negative 1. There's term 1. Second term, negative 1 squared over 2 times 2 minus 1. We get 1/3. Third term, negative 1 cubed over 2 times 3 minus 1. We get negative 1/5. Our fourth term is going to be negative 1 to the 4th power over 2 times 4 minus 1. We get 1/7. And finally, our 5th term, negative 1 to the 5th power over 2 times 5 minus 1. And we get negative 1/9. A couple of things to start recognizing when you're looking at sequences like this. First of all, in this sequence, notice that the terms are alternating from positive to negative. Identify what part in this sequence over here, or in this formula, is making the signs alternate. The part that's making the signs alternate is the negative 1 to the n power. Start being able to identify that and think in terms of what's controlling this part, what's controlling that part. It's going to help you later on in the chapter. Number 3, write an expression for the nth term of the sequence. So now we're given the sequence, and we need to come up with one of the expressions like we had on the previous few slides. What I would do to begin is always write down the term and the value of the term. Term number and the value. Third term is 5. Fourth term is 7. And there's not an easy way or one blanket way that I can say, oh, look at this every time, and then here's how you get to your formula. What you need to do is come up with a relationship between the term numbers, which are these over here, 1, 2, 3, and 4, and the value of the term. In other words, what can we do to that term number to get to each one of those values? If you begin looking here at these, our nth term, well, if I take each one of these term numbers, 1, 2, 3, and 4, and I multiply each of them by 2, I get 2, 4, 6, and 8 when I multiply these term numbers by 2. And we know that 2, 4, 6, and 8 are one more than each of the term values. So if I take each of those term numbers and multiply them by 2, then I just simply need to subtract 1, and that's the formula that we could use to get any of those values. Letter B. First term is 2. Second term is 5. Third term is 10. Fourth term is 17. Now, the first thing to look at in this one is the fact that there is nothing that we can multiply each one of these by, because we have the difference here is 3, difference here is 5, difference here is 7. Okay, we're over here. That made a little bit more sense. So in this first one, a of 1, or the first term is 2, the second term is 5, the third term is 10, the fourth term is 17. So we need to think about something other than just multiplying here. Okay, other thing that you should think about other than multiplying is powers. Are there any powers that I could put on these term numbers? Well, 1, we know 1 raised to any power is just 1. So let's go to terms 2, 3, and 4. Term 2, if I square it, 2 squared is 4. 3 squared is 9. 4 squared is 16. Well, 4, 9, and 16, when I look at those, are very similar to the numbers that are the actual values. They are all 1 less. So the nth term here I can find by squaring the number and then simply adding 1. A recursive sequence is a sequence in which each term is defined based upon the previous term. If we think about term numbers, first term obviously is first, second term, third term, and so on. Eventually I would get to an A of k term. Well, to get to the next term number, to go from term 1 to term 2 to term 3 and so on, we're adding 1 each time. 1 plus 1 is term 2. 2 plus 1 is term 3. 3 plus 1 would be term 4 and so on. So the term that would come right after our A of k term is our A of k plus 1 term. The next term would be our A of k plus 2 term, and so on. The term that would come right before A of k is A of k minus 1. Right before that, A of k minus 2, and so on. So again, the importance of being able to identify term numbers and knowing these relationships is going to be very important throughout this chapter. So looking at our fourth example here, given that the A of 0 term is 1, the first term is 1, the kth term is the k minus 2 term plus the k minus 1 term. We want to write the first 6 terms of this sequence. Well, I know the first 2 terms that were given. The 0 term and the term 1 are 1 and 1. We need to write now the next 4 terms. This is the key right here. Where does the k term come in relationship to the k minus 2 term and the k minus 1 term? Well, if I look right back here, here's our k term, here's our k minus 2 term, and here's our k minus 1 term. So that means to get this term right here, I need to take the term that is 2 in front of it and add it to the term that is directly in front of it. That's what this is telling us right here in the box. To find that kth term, I take the term right here that is 2 in front of it and add to it the term that is directly in front of it. So if I want to find this term right here, I'm going to look at this term 2 in front of it, the term directly in front of it, add those 2 together, we get 2. To get this next term, I'm going to take the term that is 2 in front of it, the term that is right in front of it, add those together, we get 3. To find this next term, add together the two previous terms. Get the next term, add together the two previous terms, and so on. There are the first 6 terms of that sequence. Factorials. Factorial is just a shorthand way of writing a repeated multiplication. Specifically, what a factorial tells us is take every single integer, one less than whatever's in front of the factorial symbol, and multiply by every single one of those integers one less. So 3 factorial, I take 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1. 5 factorial, 5 times 4 times 3 times 2 times 1, all the way down to 1, and it's just a shorthand way of writing out that multiplication. So n factorial is going to be n times the term that is 1 less than that, so n minus 1, term 1 less than that, n minus 2, n minus 3, n minus 4, n minus 5, and so on, all the way down to 1. Multiply all of those together. So using factorials in a sequence, no different than any other sequence, right? The first 5 terms beginning with n equals 0. So we want to find a of 0 first. It's going to be 2 to the 0 power over 0 factorial. First term, 2 to the first power over 1 factorial. Term 2, 2 squared over 2 factorial. Third term, 2 cubed over 3 factorial. Fourth term, 2 to the 4th over 4 factorial. Simplify each one of these. 2 to the 0 power, anything to the 0 power is 1. 0 factorial is defined to be 1, so we get 1 there. 2 to the first power is 2. 1 factorial is 1. We get 2. 2 squared is 4. 2 factorial is 2. And 4 divided by 2 is 2. 2 cubed, 8. 3 factorial, 3 times 2 times 1 is 6. We get 4 thirds. 2 to the 4th power is 16. 4 factorial, 4 times 3 times 2 times 1 is 24. Simplify 2 thirds. There's the first 5 terms beginning with n equals 0. Okay, evaluating factorials. 8 factorial divided by 2 factorial, 6 factorial. Now, these can be done very easily on your calculator, but you're going to need to know how to do this process without the calculator because it's very easy to overload a calculator by just putting in something like 90 factorial. It's too big of a number for your calculator to work with. So 8 factorial. Remember, 8 factorial I could write as 8 times 7 factorial. I could write it as 8 times 7 times 6 factorial, 8 times 7 times 6 times 5 factorial, 8 times 7 times 6 times 5 times 4 factorial. In other words, when you go to write out a factorial, you can stop at any integer value you want to and simply add the factorial symbol behind that. And remember, that just would represent the rest of the multiplication. Well, in this case, what I want to look for is for some factorials to cancel. So when I look at this numerator, I want to rewrite this as 8 times 7, and I want to stop at 6 factorial because that's going to cancel with the 6 factorial here then down in the bottom. So these 6 factorials cancel. I'm left with 56 divided by 2, and 56 divided by 2 is 28. Letter B, 6 factorial up top. I want to write as 6 times 5 factorial. I'm going to leave the 2 factorial alone. I'm going to leave the 5 factorial alone. I'm going to rewrite the 3 factorial as 3 times 2 factorial. Now our 5 factorials cancel. Our 2 factorials cancel. I'm left with 6 over 3, and 6 divided by 3 is 2. Letter C, n factorial over n minus 1 factorial. You want to look at the biggest of the two numbers. In other words, the biggest one isn't always going to be in the numerator. It may be down in the denominator, and then that's where you want to start. In this case, n is bigger than n minus 1, so I want to start there. I know n factorial is n times n minus 1, and that's where I want to stop, because now our n minus 1 factorials are going to cancel, and we're left simply with n. Let's look at this very quickly on the calculator. If you go into your math menu and over to probability, you see the fourth command underneath there is your factorial symbol. So if we look at the problem that we just did in letter A here, 8 factorial. 8 math probability number 4, 8 factorial divided by, I'm going to divide by 6 factorial times 2 factorial. We get 28, which is the same thing we got by hand. Remember, your calculator is good to check these on, but on a quiz or a test, it would be very easy to put in something like 90 factorial, and you're not going to be able to simplify that on your calculator, so make sure you understand the process that we went through with the previous examples.